Today we're going to cover still chapter 5, section 1. Today will be day 2. Today we're going to learn how to solve exponential functions. We're going to be solving for a variable. Most of the questions will have the variable in the exponent. One of the last ones I believe will be solving for the base. So yesterday we covered graphing the exponential functions. And remember, all we did was make a little chart and we plugged in values. Again, you're going to plug in a negative, a positive, and 0, and then memorize the shape that they take on. So today we're going to solve. So this is the general shape that your exponential function takes on as long as there is no shifts to it. Memorize the transformations. Remember, when it's a vertical transformation or translation, it's going to be shifting it up and down. So this will be the up and down translation. And whenever you add something to the base, that would be up. Whenever you subtract, that'll be shifting it down, just like what you would think logically. The horizontal, though, however, this is the left and right, and this is backwards of what you would think. So when you're adding something to the exponent, it's shifting it left. And then when you're subtracting, it would be shift to the right. When there is a negative in front of the base, that would be a reflection across x. When there's a negative sign in front of the power or the exponent, that will be a reflection across the y-axis. And then when there's a number in front of the base, that would be vertical stretch or shrink. If it's greater than 1, it's a stretch. If it's a fraction, a number between 0 and 1, it would be a shrink. And then a number in front of the exponent, that would be a horizontal stretch or shrink. Again, if that number in front is greater than 1, it would be a shrink. And if it is a fraction, a number between 0 and 1, it would be a stretch. And then we graph some examples using or applying these transformations. So that brings us to where we are now, which is called the one-to-one property. So this is going to be a technique that we can use to solve an exponential function. So again, our base, our a value, has to be greater than 0. It can't equal 1 though. And what we're going to do is we're going to try to make the two bases on either side of the equal sign to have the same number. And when that occurs, so for example, if I have 2 to the x power equals 2 to the third power, I'm going to be able to get rid of my bases and then just set the exponents equal to each other. Now, it's not always going to be given to you with the bases already the same. This is where we're going to need to memorize what 1 squared or what 2 squared is, 2 to the third, 2 to the fourth, and be able to change the numbers so they have the same base. And when possible, you're going to change the larger base to the smaller base. Now, sometimes you'll have to change both numbers so they have the same base. And then again, remember, anything raised to the power of 0 or 0 power is 1. So just a little preview of what's to come. You're going to get something like 2 to the x is equal to 8. So what we're going to try to do is make this larger base into the smaller base. So this is where it'll pay off. If you know that 2 to the third power is 8, we would change the 8 to 2 to the third power, leave this one the same. Now the bases are the same. Get rid of the 2's, and you set the exponents equal to each other. So essentially, this is a little preview of what we're going to be doing in the examples. One other thing to remember is that whenever you have a negative exponent, remember that equals a fraction. And then remember, whenever you have a fraction or a rational exponent, that means the square root. Remember, the denominator is the root. So we'll be using this information when we're trying to change, like the square root of 4, and we want to make it a base of 4. And then this would give us 2. Okay, so here is my first example. Again, my goal is to try to make the larger base look like the smaller base. Sometimes it works in every problem, other times you have to change both. So I can actually change the 9 and I can make it have a base of 3. I can change 9 into 3 to the second power. And then leave this one alone. I now have the same base, get rid of the 3's, and now I solve what remains. 2 is equal to x plus 1, and now I'm going to solve by subtracting 1. 2 minus 1 is 1, so x equals 1. Now, what's nice about these, when you do them, you can actually check your answer by plugging in what you just got for x. So, for example, if I wanted to check this, I would take my original problem, 9 equals 3 to the x plus 1 power. I'm going to take out x, and I'm going to put what I just found, x equals. So once I plug in a 1 for my x, 1 plus 1 is 2, 3 squared, and 9 equals 9. So if it doesn't equal that number, then you've done something wrong. So this is a nice way that you can check. This one, I'm going to change both of the bases. Okay, instead of trying to make 8 into have a base of 1/2, I'm going to change 1/2 so it has a base of 2. So what I can do here is change 1/2 to 2 to the negative 1 power. Then put the x, so I leave that exponent that's there. Then I'm going to change 8 and make it 2 to the 3rd. I have the same bases, get rid of the 2's, and now I'll multiply. Remember, a power to a power, we need to multiply that. So it's negative 1 times x is equal to 3. I can't solve or leave a negative variable, so divide both sides by negative 1, and x equals negative 3. So again, if I wanted to check this one, I would take 1/2, raise it to the negative 3 power. Remember, whenever you have a fraction raised to a negative exponent, think reciprocal. So flip it, make the power positive. 2 over 1 is just 2, and 2 to the 3rd equals 8, and that's what I was trying to make it equal. So my answer is correct. Let's try the next one. For the next one, I only have to change the 8 and make it the smaller base, which is 2. So for the next one, I'm going to change the 8, and I'm going to make it 2 to the 3rd power. I'm going to leave the right side of my equal sign exactly the way it's given. I now have the same base, get rid of the 2's, and solve what remains. 3 is equal to 2x minus 1. Add the 1. 4 is equal to 2x. Divide by 2. And 2 is equal to x. So again, what I was saying at the beginning, I would work on knowing what 2 squared is. So 2 to the 1st is 2. 2 squared is 4. 2 to the 3rd, 8. 2 to the 4th, 16. And also know that 2 to the negative 1 means 1/2. Do the same thing for the 3's. 3 squared, 9. 3 to the 3rd, 27. Do the same thing for the 4's, the 5's. If you look at the problem and you're like, I don't know what it is, then over to on your scratch paper, start multiplying the numbers. Granted, I'm not going to give you something super huge on the quiz. Okay, so if you get something that isn't some of these smaller ones, then just do the multiplication to the side. All right, so for this one, again, I'm going to change both of them. Now I'm going to show you two ways. First, I'm going to go ahead and change the 1/3, and I'm going to make it 3 to the negative 1, and then put the negative x. Then I'm going to change the 27 into 3 to the 3rd. Get rid of the bases and solve what remains. So negative 1 times negative x equals 3. Negative 1 times negative x is positive x, and x equals 3. Now, another way you could have thought about this is you could have taken this, and if you just deal with the negative sign and think, you know what, when I have negative 1/3 raised to a negative x, I could change this and flip it to the reciprocal and get rid of the negative. Go ahead and just finish it up. So this is what it was initially. So then if you first just take care of the negative sign, then you have 3 to the x, and then this is just now this, and then get rid of the 3's, and then just you're right at your answer of x equals 3. So you can do that if you have a fraction raised to a negative power. If you want to get rid of the negative sign first and then change the base, you can, or just change the base to a negative exponent. So for the next one, this one, the power isn't negative, so I actually have to change the 1/3 and make it 3 to the negative 1 power. And then 81, this is actually 3 times 3 times 3 times 3. So again, if you didn't know that 3 to the 4th power was 81, then you would have started multiplying. 3 times 3, 9. Times 3, 27. Times 3 again, 81. Or if you want to do them 2 at a time. 3 and 3 is 9. 3 and 3 is 9. And then do 9 times 9 and get the 81. Doesn't matter how you're going to get it. But again, if you didn't recognize 81, then start multiplying. You could have done the 2's. Obviously, 2 to any power is going to be an even number. So that would have been a clue that 2 wouldn't have worked. So then I would have gone to 3. If once you start doing 3 times 3 times 3 and it gets too big, go to 4 if you're not sure. So now I got the same bases. Get rid of the 3's. Take what remains. So negative 1 times x. And negative 1 times x is negative 1x. Divide by negative 1. And x equals negative 4. And again, you can still do the check on all of these. Next one. I need to look to see, can I make that 8 into a base of 2? Yes, I can. I'm going to make it into 2 to the 3rd. So this one stays the same. Change the 8 to 2 to the 3rd. And then put the x minus 6 up top there. Get rid of the bases. Now, the 3 needs to distribute to the x and to that negative 6. So power to the power, we multiply. So I'm going to distribute the 3 to the x and to that negative 6 and get negative 18. Drop down this side. And now get your variables together and your constants. Doesn't matter which way you move it. So if you want to move the x over to the 3x, you can. I know everybody tends to move it to the left. It doesn't really matter as long as the variables end up on one side and the constants on the other. And then we'll add 18. I get 22 is equal to 2x. Divide by 2, and x equals 11. Okay, so for number 21, again, I need to see, can I make that bigger base into the smaller? Yes, I can. Again, I can change the 8 into 2 to the 3rd power. And then the other side, leave it exactly how it is. I have the same base. Get rid of the 2's. And now set the exponents equal to each other. I'm going to go ahead and subtract 3 from both sides. Negative x equals 0. Divide by negative 1, and 0 divided by negative 1 is still just 0. 0 is a valid answer because watch, if we check this and I plug it in, 3 minus 0, 3 minus 0 is 3, 2 to the third power is 8, so 0 is a good answer. So when we're solving these, we can get whole numbers, we can get integers, we can get fractions, we can get 0. It's all fair game. Okay, so you can get fractions, negative numbers, positive numbers, 0. They're all valid answers. Let's try the next one. Oh, now we're going to change it. No more 2s, no more 3s. Okay, what can we change 25 into? 5 squared, right? So then change this to a 5 squared. And now we have the same base. Get rid of the 5s. Take the exponents. Set them equal to each other. Subtract 1. 2x equals 1. Divide by 2. And x equals 1/2. So here we go. We got an answer that's a fraction. And it does work. Because if I were to plug it in, and do 2 times 1/2, that's 1. 1 plus 1 is 2. 5 to the second is 25. Now the next one, it's got an e here. We're still not using our calculator. Remember, we're just changing the bases. It's got the same base. Just get rid of the e's. So all I do is get rid of my e's. Let me just rewrite it. I didn't have to change anything here. It had the same base. So drop the e's and work with the exponents. So 4 to the x minus 1, power to the power, multiply that 2 and x, and you get 2x. And now get your variables together. So subtract 4x. Negative 1 equals negative 2x. Divide by negative 2. Negative divided by negative, positive 1/2, and x equals positive 1/2. So here I'm going to distribute and multiply. So 3 times 4x gives me 12x. Distribute the 2. 2 times x, 2 times 1. And now I need to get my like variables together. So I will subtract 2x from both sides. I get 10x equals 2. Divide both sides by 10. X is equal to 2/10. Simplify this fraction, divide them both by 2, and I get 1/5. Just take your time, show the work. Next one, I can change that bigger base to the smaller base. I can change 4 and make it 2 squared. So I'll change the 4, make it 2 squared. Put the exponent that was originally there back. And then leave the 2 raised to the 3x plus 3 power. Get rid of the base of 2. Take the power to the power. Multiply that one. And then just rewrite this one. Distribute 2x minus 4 equals 3x plus 3. I need to solve. Now you could either move the 2 to the other side or subtract the 3. It really doesn't matter. You just need to get variables on one side of the equal sign and the constants on the other. Then I'll add the 4. Negative 1x equals 7. Can't leave a negative 1x there. Divide by negative 1. And x equals negative 7. For the next one, I'm going to change the base. They don't have the same base. So I can change 1 over e, and I can make this e to the negative 1 power and then it still has the negative x there. And then change the other one to e to the negative 2 power, and it still has the x plus 1. I now have a same base of the letter e. Get rid of the e's. So I got a same base of e. Multiply this power to the power. So negative 1 times negative x, and then negative 2 times x plus 1. I'm going to distribute and multiply here. So negative 1 times negative x gives me positive x. Distribute the negative 2. Combine my like terms. Add 2x to both sides. 3x equals negative 2. Divide by 3. And x equals negative 2/3. Remember, e is just a number. It's like 2.71 and it keeps going, just like pi. It's a decimal that continues on. Okay, so for 27, oh, we got a radical here, but we can change them to the same base because remember, we can change this square root of 2 and make it have a fraction exponent because the square root of 2 is really 2 to the 1/2 power. And then I'll rewrite the exponent that's there. I also have to change the 4 and make it 2 squared, and then put the x. I'm now going to get rid of my base of 2. I'm going to take that power to the power, and I'm going to multiply it. And then the same thing here, 2 times x. I need to distribute the 1/2 to the x and to the 4. I end up with 1/2 x plus 2 equals 2x. Now, you can either choose to work with this as a fraction. I'm going to clear the fraction. I'm going to multiply everything by 2. I'm going to do it both ways for those of you who like to work with fractions. So what I can do here is multiply everything by 2. So when I distributed 2 to the first term, I end up with just x, and then 2 times 2, 4, and then 2 times 2x, 4x. And now it makes my problem a little bit easier to solve. Subtract x. 4 equals 3x. Divide by 3. And x is equal to 4/3. Now, let's say at this step right here, you didn't want to times it by 2, and you're like, I'm going to work with the fraction. So what you would do is you would subtract 1/2 x from both sides. I need to find a common denominator here. So what I would do here is change this 2x, and I could make it 4x over 2, and then subtract the 1/2 x, which gives me 3 over 2x. So then I have 3 over 2x. Now I have to divide by 3 over 2, which really means multiply by the reciprocal. And then I still get the same answer. So you can do it either way. I like to clear the fraction, and it makes it a little bit easier. So on this one, since I can't change 27 to have a base of b or change b to a base of 27, what I'm going to do instead is remember when you have a negative exponent, I'm going to just go ahead and turn this into what the negative exponent does, make it a fraction, leave this fraction, and now I'm going to just solve this as a proportion. So I'm going to cross multiply 27 times 1, and then 1 times b to the 3rd. So once I cross multiply, I get b to the 3rd equals 27. And then now cube root, so this is what we did at the beginning of the school year. I'm going to cube root both sides. This cancels the 3rd power, and then the cube root of 27 is 3. On this last one, again, I'm solving for a base. So really these last two are more similar to what we did at the beginning of the school year, okay? It's not what we're doing now. So for this one, I can do this one two ways. So if I take my problem, I can either raise both sides to the reciprocal power. So raise it to the 3/2 power. That cancels that. And then I'm left with r. And then over here, what I'm going to do is I'm going to square root the 4 and then raise it to the 3rd power. Remember, whenever you square root a number, we get both positive and negative, and then we have to raise that answer to the 3rd power. So then 2 to the 3rd power, this answer is going to be positive and negative 8. The other way you could have done it, now remember, you don't always have to do the root first. So at this point, another thing you could have done is you could have raised both sides to the 3rd power, which cancels the fraction, and then you get 64 equals r squared, then square root both sides, positive and negative 8. You can do it either way. A lot of times it's better to do the root first because it makes the number smaller. But not always will you be able to do the root first. Sometimes you will have to do the exponent first. So you can do it either way or do it all in one step and raise it to the reciprocal power. So for example, let's say instead the problem was 64 equals x to the 2/3 power. So on this one, if I try to do it like I just did up above, and I try to raise both sides to the 3rd power, I would have to do 64 times 64 times 64, and then find the square root of that without a calculator. So in this particular case, it would be better to do the reciprocal power and do the square root first, and then raise it to the 3rd power. That would work out better because this will give you positive and negative 8. And then do 8 times 8, 64, times 8 again would be 512. So if the number's kind of large, always try to root it first, then go back and do the exponent if you're not using a calculator. One other one, let me show you one that's not a perfect square. Let's say I have x to the 2/3 power equals 8. So on this one, if I raise both sides to the reciprocal power, what I would get here, I can't do the square root of 8. So what I could do though is I could break it down. So like if you tried to square root the 8, you would get 2 times 4, 2 and 2, pair of 2's, 2 radical 2. So you could do it like that and get 2 square root 2 and then raise that to the 3rd power. And then what this would become would be square root 2 times 2 times 2 square root 2 times 2 square root 2. And then if you multiply all these, you would get an 8. But then I could make a pair of square root 2's. So another 2 would come out. And then this poor 2 stays behind. So 16 square root 2. And these are all plus minus. So if it's not a perfect square, you may have to do something like that.